Okay, this is AGEC 305 Lab 10. We are just going to look at our first set of time series data and with a focus on replicating some of the analysis of turkey prices that was done in Professor Lusk's blog post that we talked about in lecture recently. So when you open this week's spreadsheet, you'll see that there are 3 sheets available to you. So turkey prices by time period, same thing for beef prices, and then CPI data. In both of these, we are, one of the things we're focused on is forecasting and trying to come up with an estimate or a predicted value for November prices in 2017, because that was the focus of the article. And so we will, in the lab, generate our own November 2017 forecast price for turkey, and then we'll look at the approach for beef and CPI data that Professor Lusk added. So when we get in that spreadsheet, you'll see those. And then of course our goal is to look at real versus nominal turkey prices compared to beef prices, and we'll generate this last sheet as part of the lab. Then the final thing we'll do is move over and we'll look at CPI data, which CPI stands for Consumer Price Index. It's a measure of general price levels, so that's what government. It's a government generated statistics. So they collect survey data on what people are buying and what they're paying for goods, and they track how much prices are moving over time. And so one of the things we will do is build a time series model just like the one from lecture that we've used this week and from the chapter 7 of Norwood and Lusk, where we predict the current period's price using 1 to 3 months of lags and then a seasonal factor, this T minus 12. And so we'll do that for some data, and we'll compare our predictions to some to actual observations and see how good the forecast is working. And that will give us a starting point for the lectures that we begin right after Thanksgiving break. So let's get into our lab exercises. So part 1 is just forecasting the November price. So we'll open the spreadsheet here in a minute. You'll see that the sheets are listed like this. So we have turkey prices by period. So the year of the data is the first column. So every row is a different year, and then every column in the data is a different month. Okay, so this is the way a lot of monthly data is presented. We are going to be focusing on the November column, because that's the price that we're trying to predict, and then September, which is the information we're going to use to predict that. So really only 2 columns here matter for us. The data go from 1998 to 2017, and we're trying to figure out how to fill in this missing spot. You'll see in the spreadsheet that this is a yellow empty cell. How do we fill in this missing value for November turkey prices? And we're going to use this sort of model, a regression of the current November price based on the 2-month prior 1 to September prices. And so that's a fairly simple exercise, and we'll go do that right now. Okay, I have my spreadsheet pulled up to the turkey prices sheet. You'll see the yellow cell right here. This is the one this is our target that we have to fill in. We don't know what that value is yet. These prices are they're frozen turkey prices per pound. Okay, so everything is in the same units. The prices are all nominal, not seasonally adjusted. So there's nothing for us to do here but try to fill in this using available information. And so we are told, or we were tasked with a comparison of November prices each year compared to the September version of prices. We have from 1998 to 2016, we have both all the November and September prices, so we'll use that to build up our relationship here. Yeah, so the easiest way, you probably are already anticipating this, is just to run a regression. So let's just go to the top, go to the Data tab, then go to Data Analysis, and that'll open up these options. So ANOVA, two-factor. If you scroll down, you'll find Regression, and click on OK. And then we get the regression input box here, the regression menu. So we need y variable and an x variable. Okay, and so our y variable is going to be the dependent variable. We're going to try to explain the November price using the x variable, or the independent variable, which is the September price. So the y range is going to be these November prices from 1998 to 2016. The x range, the September price from 1998 to 2016. Okay, I'll leave that sitting there for just a second. So L6 to L24 versus J6 to J24. And then the last thing I want to do is click right here for output range, and then I'll click on the red dot here and just make sure that I'm going to click, I think, O4, and that will be the top left corner of where the regression output ends up, and that's where I want it. I want it somewhere to the side here where I can use it. So we click on OK. Excel does its business, and it gives us an intercept, estimate, and a slope coefficient for the x variable. You could read through all this and see the p-value, the r-squared. As you can imagine, the price in November is highly correlated to the price in September, so we end up with an r-squared that's very high here. But as we said, our goal is to fill this cell in right here. Okay, so we have a model that says, give me the September price and I'll give you a prediction of the November price. So that means we are going to use these two values right here. As our predictor, as our method for predicting this. So we can just go down here to the yellow cell and type equals, and it's just going to be a formula. It's going to be the intercept in P20, the way I've based on where I put my regression output, but be sure you get your intercept, plus the slope coefficient 0.94 in that cell, and then we're going to multiply that by the September price. Okay, so we get that, and so we get 1.496, and you can see this follows the pattern. So so it's about 94%, and then of the September price, and then subtract 4 cents off of it. Okay, that's what this coefficient is saying. So 94% of the September price, subtract 4 cents from it, and that's what we have going on here. And you can see that the November price tends to be smaller than the September price, so that's why we are getting this behavior. Now, that means we have filled in November prices all the way through 2017 per pound prices, and so we've completed our first step. We now have all the data that we want to be able to say something about how have prices, what are turkey prices expected to be this November, and how do they compare to recent years. So we can look at these nominal values and see that turkey prices were expensive, low, low, increasing, and now maybe they've fallen off a little bit. But as you know from the stuff we've talked about in class already, we want to put these in real terms. We want to compare them to other meat prices. We want to look at these prices over time and have some sort of baseline or some comparison that we can use to say something about what are the price effects. Okay, so our steps there, just to remind us, were go to the Data tab, Data Analysis, choose Regression, and then in the spreadsheet compare the November to the September. So November's the Y, September's the X range, and then wherever you want to put the output range. Okay, if we look at the beef price data and the CPI data, you'll see that Professor Lusk took a slightly different approach to the same thing that we're doing, to filling in the November predictions. And so what I'm showing you here is that he used a function called, we used two functions. The first one he used is called the LINEST, and that's the linear estimator function. Okay, so LINEST, linear estimator, is an Excel function, gives linear regression estimates, and the nice thing about it is you don't have to use all the Excel menus. So if we look back here, right, you have to go to the data tab, click the data analysis, click on regression, and you get that big data table, that big table of all the coefficient stuff with all the t-values and the standard errors and the 95% confidence intervals. So all of that appears. But if you just wanted the estimate to appear in some cell, that's what you use linest for. So if you are primarily interested, like we are, in forecasting, it might be useful to just have a way of generating the slope coefficient and the intercept coefficient in cells so that you could use those as parameters in formulas. And that's what Professor Lusk does here. So I'll switch over to that in a second, but you can see he's comparing the blue column of beef prices in November to beef prices in September, again for the 1998 to 2016 period, so that he can predict the 2017 beef prices in November. This gives the two data columns, L5 to L23, J5 to J23, and these things on the inside are part of the linest, or the linear estimator function. The second function he uses is the index function, and the index function just points out a particular value from a set. So you see the 2 that's represented here, that is saying, give me the second thing, the second item, the index number 2, the second item of the output of this linear estimator function. Okay, so the linear estimator function, if you have this versus this, the first thing it gives you will be the intercept. The second thing it gives you is the slope. So this is a function for the slope coefficient. And so when we open that spreadsheet, you'll see that he has an index linest function here and another one here. Okay, so these cells hold the results of his estimates. Okay, so the intercept, the slope coefficient. We have information on the September 2017 price right here in this cell, 7.363, and then right here we have the formula that's needed to predict the new November 2017 price. So K3 plus L3 times J24. So this is J24. So let's switch over to the spreadsheet again. Okay, let's go to the beef price information. And you can see here that he's got the, this is index 2, so that's the intercept. Index 1, the first thing that comes out is the slope coefficient. And so he has those right here. Those functions are being generated using this column and this column. And then he uses a formula here, K3 plus L3 times J24, to predict the November 2017 beef price. Same thing needs to be done for the CPI data. We don't have a CPI yet for November 2017, but we have September information, and we have a time series of data that can be used. And so again, the same thing that we've done before, so we can predict this using an intercept and a slope multiplied by the September value for the CPI. Okay, and up here again, he's using 1998 through 2016, 1998 through 2016, and the intercept, and then the slope coefficient being estimated. So we're not going to learn the index function or the linear estimator function. I just wanted I didn't want us to do all three of the regressions using the regression tool. The data he gave us already had these produced for us, and so that's why I'm going through that. So to show you that there, whatever you can do in Excel, there are usually at least two ways of doing it. So, and I certainly know from the things that people have turned in this class that you guys have some abilities, and certainly you do things your own way. If you have your own ideas, just make sure you understand the concepts always, and that'll work out fine. Okay, let's go back to our work on our PowerPoint with some overview information. So the CPI data sheet there, we used the same method to forecast the November 2017 CPI. But the next thing we have to do is actually come up with, so now that we have all of our data filled in for November 2017 using these predictive values, we have to go back and calculate a CPI index so that we can convert all of our nominal prices to real prices. And so that's where using a CPI index comes in. So the price relationship, or the formula that we use to convert nominal prices to real prices, is fairly simple. So CPI is a true measure of the general price level, and so the right hand side of this expression here, which says nominal over the base year price of whatever good you're looking at, is equal to the nominal versus the base year CPI. Okay, so T is sort of this current year, B is the fixed or the base year. You're going to measure something in 2017 dollars, then B is going to be equal to 2017. Okay, so the CPI is this sort of normalizing set of data. The turkey prices that we're going to look at, or the beef prices, are just what they are, right? So they're going to be the price of the November price in 2015, 2014, and we need to convert those to 2017 dollars. So we'll take out the value of that. An easy way to rewrite this formula is just to take, so this ratio is on one side of the equation, so that means we can divide both sides by this. That would leave a 1 here, and multiply both sides by the denominator on this side. Oops. And we'll end up with this price relationship. So we're going to get, to convert our turkey prices or beef prices into base year 2017 prices, what we need to do is divide the nominal price by this ratio, CPI in year T over CPI in the base year. So our steps, 2 steps. One, we're going to pick a base year. We're going to let 2017 be the base year. Divide all the CPI data by that 2017 CPI value. Then we're going to come back and divide all the nominal prices by those ratios. Okay? PT, the nominal price, divided by this ratio, will give us our base year or real prices, or prices in 2017 data. $2017, sorry. Okay, I have my spreadsheet open to the CPI data sheet, and I'm going to make my CPI index column right here. That's going to be in 2017 dollars. Okay, and we said just divide each year's price, and we're actually going to start with 1998 because those are the only all the values we have start with 1998 for turkey. So we'll start right here, and we're going to divide every year's CPI in November by the November 2017 predictive value. Okay, so the formula we're going to use out here is start with an equal sign, take the November November CPI value, L4, and then we're going to divide it by L23, which is the base year. And to make that cell reference so that it doesn't move, I'm just going to hit F4 once, or you can type the $ in front of the L and the 23, and that gives us that fixed reference. Okay, so that means we can copy now all these values down however you want to do your copy. And you can see every time in these formulas then L23 is used as the base. So these are just what is this CPI level in November of 1998 or 2001 relative to the 2017 year. So if this is a measure of the general price level, then the way we can normalize or sort of convert turkey prices to $2017 is to make 2017 this 2017 coefficient here, and we'll use that and we'll divide all of our prices. Okay, so our last step then is to just create a new sheet. So I did insert worksheet. I'll move it there. I want these cells to be bigger so you can see them. Okay, and so what we're going to do is we're going to make a set of columns here. Okay, I finished making my columns. You can pause it and make yours look like this as well. So these are all measured in November. So our analysis is really for November prices, where we're going to look at the turkey nominal, turkey real, beef nominal versus beef real, and then 1998 through 2017, because that's the information we have. Okay, and so to get the nominal prices, I'm just going to make a cell formula here that says this is turkey nominal 1998 is going to be equal to, go to your turkey price sheet, the November nominal price 1998 for turkey is right there in cell L6, hit equals, and it gets copied over, and then you can copy that formula straight down, and you'll have all of your turkey prices, November turkey prices in nominal terms for the entire period that we have. Do the same thing for the beef nominal prices. So beef nominal is going to be equal to November 1998 L5 on this sheet, hit equals. We have that, so you can see here it's saying go to the beef period prices sheet and find cell L5. If you copy this down, the formulas follow through, and it says keep moving down that column in that sheet. Okay, so now we have all of our data on nominal prices, and we just need to do the conversion to real. And so this will be a formula that first looks at this nominal price, and then it divides it by that CPI value that we have. And so let's go with turkey. The real price is going to be equal to the nominal price, that PT, that's the nominal price, the 1998 November price for turkey. Take that in B4, divide it by, from the CPI data, the 1998 November CPI index. And we calculated that right here in O4 on my sheet. Hit enter. Look at that formula so you can see. Take B4, divide it by the CPI data sheets O4, and then we'll copy everything down. Okay, and you'll know you have a winner if in 2017 you get the nominal price equal to the real price, because 2017 is our base year, things are measured in 2017 dollars. That means the nominal and real has to match up for 2017 November, and that's what we have right here. So go ahead and fill in yours for beef real. I'm going to pause this just so there's not a bunch of more recording of me doing stuff on the sheet. Okay, I have all my data filled in. I have nominal real. These two match up. Be sure that happens for you, and that means that the 2017 prices match up. Then let's do one more thing. So we're going to graph this. I'll start it with you and then show you what the final graph looks like. So let's start with clicking somewhere over here so that we end up this sort of will be the location for our graph. And let's go to insert, and then the graph type we want is right here. It's called the XY scatter type. And so if you click the little down arrow next to it, you can actually pick this one, which is straight lines connecting dots, or this one, straight lines without the dots. I think I'll go with that one. And so what you end up with is this graphing space that doesn't have anything in it yet. So you can right click, go to select data, and now it's just waiting for you to add some data series to it. And so the data series that we're going to use, when we click on add, for the series name we'll just use, I guess I'll just type something. I'll type TKY nom. So the turkey nominal, and for the X values we're going to put years. So we want the years to be the x-axis. The time element will be the x-axis. And then for the y-axis we're going to add the nominal prices. So you highlight all those, and you get your first sheet, first set of results. So turkey nominal series over here tells you what's on the horizontal axis, so all the different years, and then you can see there that my price is the price series going from 0.93 or something like that up to about 1.5. Okay, so let's add another series, and let's go with the turkey real. The X values, you have to put them in every time. For these, every time we add something, are going to be years again, and then the Y values will just be the real prices for turkey. Okay, click on that, and then scoot that out of the way, and you can see the deflator, right? So the value, as you move up, the CPI gets closer and closer to 1, and at the end it's exactly the same. And so we've set this up so that the difference in real versus nominal is going to be shrinking as we move down this graph, so it's almost like it's tilting the graph. I'll let you keep going, add 2 more series, one for the beef nominal and beef real. Do that on your own, and when the video is going to jump ahead to when that's complete. Okay, so what you have now is a turkey prices, beef prices. Beef prices are more expensive. If you follow through with the blog post, you could divide these prices by these prices and get the ratio of prices. You can see that in the commentary in Professor Lusk's blog post, he talks about turkey prices being very stable. Well, that shows up really well, right, compared to these beef prices, which are have some volatility and have also been increasing relative to turkey prices over time. So you can do any of that stuff you want to. I would suggest that you look into modifying your graph a little bit here. I'm not going to have you print it out and submit it because we're not back in class next week. But if you just highlight, as long as the cursor is clicked and you have these dots around it so that this is the area, the chart tools will have this design tab open. And if you move all the way to the left here, it says add chart element. So you can add axis titles. You could get the horizontal axis labeled like this with year, and then maybe remind yourself that we're actually focusing on the November price of each year. You could put dollars on the vertical axis. You could add a legend like this so that every one of your series is marked as different for colors, and then of course you could highlight one of the lines here, and by clicking on Format Data Series, you can change the way the line looks so that you get a broken line. If you were going to print this in grayscale, black and white, some kind of monochrome thing, you can change the way the lines look so that they're easier to spot the differences in than just color. Okay, so with that, I think we'll stop the replication part of this and move on to our last task. And so you have in your sheet this tab called CPI one column. Okay, and so what I want to do there is get our first look at trying to build out a lag system for time series data. Okay, so if you look at this data sheet, it has a column A which has the year, a column B which has the month, and then column C which is the actual date. Okay, and so that's just, if you look, it's using this concatenate formula for 1998 and January, put those together with a dash in between. And that's because we have two components when we talk about the time element here. It's a month and year, so it's January of which year, February of which year, and so we have to do all of those. And then we have the final column here, which is the CPI, or this general price index level from each of the years in the data. Okay, and so what I'm going to do, what I'm going to suggest we do is maybe go down to 2005 and you just pick how you want to do it. But what we need to do is set up our lag prices. Okay, and so if we were to make this easier, I'm going to put a break right here. Okay, and so now in December of 2005, the price one period ago was the November price. And so one of the ways I could do that would be to set that price equal to the one, set this price to the right equal to the one above it. So this would be then in December of 2005, the November price is the 1 period lag. The 2 period lag is the October price. And then the 3 period lag is going to be equal to the September price. So now I have December, November, October, September. And so if I were going to try to predict or build a model that says let's use the December price and try to explain it using P in T-1, T-2, or T-3 all together, then now I have the 3 columns here that I need. And then the last thing that we needed was the 1 year ago price. So let's set that one equal to, right here in cell D85, that's the 12 month ago price. That's the 12-month lag. So now I've got 4 items of data. They're all in formulas. And so if you want, I do this one column at a time. You can copy formulas up, and that's the right way to do it in this kind of data. And you see that it copies all the way up except for this first column copies itself all the way up, except here you don't get a value, right? You end up with this text that you don't want, and that's because for January 1998 we don't have anything that serves as the 1 month prior price. Our data stops there, so when we start doing these lag models, we actually lose an observation. So that one goes away. And if you want to copy these others up, you'll see the same thing, except you're losing an extra month. Okay, so copy that one up, and now you end up with something there that means nothing. And then copy this one up. And we have nothing there. Okay, so that means we're going to lose all of this information. And now, when we go to this, 12 months ahead, what do you think we're going to lose? Yeah, we're going to lose all of that. So we lose, if we want to use a 12-month lag, we lose 12 observations. This is just one of these sort of issues in time series modeling. Every lag you introduce means you lose one period of data. Okay, and so you lose up to the maximum lag that you use. So if we use a 12-month lag in this model, that means the first year of data is gone because we have no way of modeling what, when we look at December of 1998, we don't know what the price was in December of 1997 to fill that in. So essentially, if we want to use the data that we have for a model like is presented in our handout here, like this, our first time series forecast model, if we want to do that, then we have T-1, T-2, T-3, T-12, so we're going to lose 12 months worth of data in our sheet. And at that point, we could run a regression on what we have left. So if we want, the more lags you introduce, the more data you're giving up, and that's just one of the things that happens because there's only so far back that you can go. I'm going to pause this and finish out the regression and show you what we can do next. Okay, so you can see I've got my regression put together here. So what are we going to use for the Y range? We're going to use the column that we have CPI time T. So we're going to use January 1999 all the way down to D97, which is December 2005. Okay, and then for the X range, we're going to use column E, F, G, and H that matches up to that. Okay, so we have the Y range, or the current price, is depending on these columns that we built to use 1 month, 2 months, 3 months prior, and 12 months prior. Okay, and so it's just a standard regression. I want to make the output appear right here and click on OK, and you see what we get. 1.4 minus 0.9, 0.43, and then some small effect from 12 months ago. Now, take that. If we have these, we could, you see the higher squared, all this stuff. But what becomes interesting is we could use the data, the prices that we have right here to predict going forward. So if you want to make a prediction about so this data stops with December of 2005. If you want to predict the January 2006 price, then you need to know the November price in 2005, December, October, and the previous January's price. So you can use these coefficients right here, the intercept, and the 4 slope coefficients to predict the January price in 2006. So I'm going to copy these and bring them all the way down here. Okay, and so let's make a prediction. Let's just put this column right here as our predictions. And so our predicted price for January of 2006 is going to be equal to the intercept plus the first coefficient multiplied by 1 month ago's price plus the second slope coefficient, or the second estimate, times 2 months ago plus the third coefficient times 3 months ago, October. Okay, so you see I've got coefficient times price, coefficient times price, coefficient times price, and then I need one more plus this coefficient, and now we have to go all the way back to 12 months ago, January. Click enter, and you can see how far off we were. Okay, and if I had done this a little bit better, I would have made J102. You can go up here and click on these J102, J103, J104. Click in the middle of those and hit F4, and you can make those references permanent. Okay? And if we do it that way, then we're not going to be able to copy those because we have to start building in the predicted prices. Okay, so you could build this out. And so what we're going to do going forward, the next time we do this, is come up with a set of price predictions, but we could build this formula out and keep predicting these over and over. And of course, what we do then is we used, I think, 6 years of data up here to come up with this predictive model for prices. And we can already see that we have some error in predicting next January's price. And we can see how far off were we, right? And so this is what we call out-of-sample testing. And so this is something we'll talk about as we move, as we continue our work here. Use some of your data to build the prediction model. Save some data to see how good you are at predicting using the past data, because that could be a good indicator of how good are you going to be at predicting when we don't know the future, right? Because at some point you run out of data. 2017, for instance, there'll be no more data, and so we're only in the dark about 2018, 2019 prices, and so we want to know how good is this model at predicting internally with the data that we already have uncovered, and so that's what the task is there. Okay, with that, there's a quiz that goes with this lab, a simple quiz to take, and that you can do right after you finish this. So I think that's the end of this lab, and we'll shut it down right here.